Boom. Okay. So again, I have a bullet. It's fired from the ground. So as soon as I see something fired from the ground like that, it's at an angle of 40 degrees. It's going to go up. It's going to come down. Projectile motion. Nice even shape. Here's my 40-degree angle. I gave you an initial velocity of 600 meters per second. I didn't say in the x or y direction, so it's going to be along this angle. So my 600 meters per second is going to be right up here, which means some of that's going to be in the VIY direction, my initial velocity in the y direction. Some of it's going to be in the x direction. So what do I do first? Pick one. VIY. How do I find it? It's my opposite side. What do I use? Sine of 40 degrees equals VIY, which is opposite, over hypotenuse, which is 600. So I just do sine of 40 multiplied by 600. Gives me 385.7. So my VIY, 385.7 meters per second. Every time you put something in one of these tables, I want to see units. Meters per second. VIX, same process, except cosine, because I'm using the adjacent side. 40 degrees equals adjacent, VIX, over hypotenuse, 600 meters per second. 40 times cosine of 40 times 600. Sorry. 459.6, thank you. 459.6 meters per second. So I have a VIX, I have a VIY. This one, I don't have to find my maximum height. I'm just looking for all of my variables in the x and y dimensions. So I'm looking to fill up this side of the table, fill up this side of the table. Not a problem at all. First of all, acceleration in the x direction. What is it going to be without any air resistance? Zero. Zero. This is just an assumption we're making for these problems. There obviously is going to be air resistance, but for these problems, we're going to use zero air resistance. What about my acceleration in the y direction? Negative 9.8 meters per second squared. All right. What do I know about VFX? Final velocity in the x direction. Same as it was at the beginning. I have no change in velocity, which is my acceleration, so 459.6 meters per second. It will remain at that same velocity the entire time, moving in the x direction. Displacement in the y direction. Zero. Zero. Starts on the ground, ends on the ground.
Like that dude who jumped off the building.
He didn't start on the ground.
Well, I mean, yeah, he did. Like, he got up there somehow.
All right, so 0, I have an acceleration, I have an initial velocity. Remember that generally, the best one to solve for first is going to be time, because time applies to both the x and y sides. If I have time, then I can come over here to the x side and solve for dx. All right, so let's come over here to the y side. Let's use the same equation we've been using, that first one. dy equals diy times t plus 1/2 a t squared. We're going to start plugging in variables. I have 0 down here for my displacement. VIY is 385.7 meters per second multiplied by my time plus 1/2 times negative 9.8 meters per second squared times time squared. Okay, we're getting there. 1/2 times negative 9.8 meters per second squared is negative 4.9 meters per second squared, so 0 meters equals 385.7 meters per second times t plus, whoops, already multiplied that together, negative 4.9 meters per second squared times t squared. Now, I have a negative over here. What can I do with it? Add it to both sides. So negative 4.9 meters per second squared times t squared plus 4.9 meters per second squared times t squared. So do that to the other side as well. Plus 4.9 second squared times t squared. So I'm going to end up with 4.9 meters per second squared times t squared equals 385.7 meters per second times t. Now what? Divide each side by what?
T.
T. Gets rid of t over here. Gets rid of one of the t's over here. Leaves me with 4.9 meters per second squared times t equals 385.7 meters per second. Now what? Divide each side by 4.9 meters per second squared. $385.7 divided by 4.9 gives me 78.7. Check the units. Meters per second divided by meters per second squared. Meters cancel out. One of the seconds cancels out, leaves me in seconds. So my time equals 78.7 seconds. It's a long time. Over a minute. Also kind of nice because it fills in both sides. Now, VFY is the only thing I'm left with. What could I do to solve for VFY? I could use the third equation. Here's something else I can do. This is a little easier. Its initial velocity was 38.7 meters per second. It went up, it accelerated downward at negative 9.8 meters per second squared, so it slowed down the whole time. Once it got to the top, it then sped up over the exact same distance with the exact same acceleration, which means its velocity at the bottom is also going to be 385.7 meters per second. In which direction? Downward, so it's negative. So, with some rounding, if I plugged it into the third equation, I would get approximately negative 385.7, but I know that it's going to be the same thing because my ground is on the same level. I have the exact same acceleration the entire time, at negative 9.8 meters per second squared. We filled up the chart. Good? Okay, let's shut this thing off.